right, so this one is exactly like the hot air balloon problem that we did in our notes. So the balloon went up and went down. You're given this rate function. This one is about a car that's driving closer and further away from home, and this is the rate of the car for 0 to 11 hours. This was a big road trip here. And you do have an initial condition that's not 0. The hot air balloon started on the ground, but this car is not starting at home. Assume the car is initially at a distance of 65 miles from home. So that's where you're starting. So what we're going to do is type this into y equals and take a look at it. So go ahead and go to y equals. I'm going to clear out the snowing problem that we did. And I'm going to type in this one. So -1/4 x cubed plus 5/2 x squared minus 6. So you're just going to go to y equals, type that in. Now, we're not going to just hit graph. What do I need to change for this one before we go and look at it? What do I need to adjust? Before I hit graph, guys, what do I have to change? Yeah, someone said it privately to me. I was hoping I would get more answers. Good, window. These are our boundaries. We need to go and change our window. So I'm going to go to window, and the x's need to be 0 to 11. I'm going to leave the y's alone for right now. You may want to change those. You can wait and see what it looks like, but the x's definitely need to be whatever's given in the problem. So 0 to 11. So I'm going to hit graph. And that looks pretty good. I think I'm going to change the Y window. Well, I guess we don't really need to. I don't need those values. Whatever. You can change this if you want to. I'm not going to bother. All right. For the sake of time here, I'm just going to leave it as is. I can see everything I need to. So letter A, when is the car closest to home? Closest to home means a minimum. Closest to home is a minimum. That is where the derivative changes negative to positive. So when you look at this, we have a change from negative to positive right here. So we are going to calculate that 0. Again, this is heavy on the calculator usage. If you can't use the calculator, you're not going to be able to get through these problems. Make sure you're practicing with me. All right. So we're going to do second trace and choose choice 2. Now it looks like this is really, really close to 2. So I'm going to make my left bound be 1 enter, my right bound be 3 enter, and then my guess is 2 enter. And it will come up 1.700. You know what? I'll round that one up. 1.701. If I would round up that other 0. So 1.701 hours. All right, so that is the time when the car is closest to home. Now, follow-up question, what is its distance at that time? All right, if you want to know where the car is, you take the initial condition, this is where it started, 65 miles from home, plus its accumulation, and we want to go from 0 until this time. You're going to have to copy and paste it. So from 0 until that time, we're going to store it as A and do a copy paste and then R of t dt. All right, so the way that you store this is you're going to quit out of there, go back to the home screen. How do I bring it back? We've done this several times here, so I'm going to be asking you guys now, how do I bring it back? Yeah, well, I do need X. I'm going to do X enter. Good, X enter brings it back, and then store. So store alpha A enter. So X enter brings it back, and then you can capture it. So store alpha A enter. And then I'm going to type this initial condition plus displacement. So 65 plus integral 0 to A, and then the R of t function, which was -1/4 x cubed plus 5/2 x squared minus 6. So I just put that R of t function in there, -1/4 x cubed plus 5/2 x squared minus 6 dx, and that will spit out your answer at you. So look how much work I did by hand. Literally nothing. Like this is that answer I got from the calculator, and then you have to set this up. And I wrote on the test, write out what you typed in your calculator. So you have to write this out. But then here's the answer. We did nothing by hand. So you have to be able to use the calculator. So this is 58.372. Now that's the distance from home. So that is in miles. So at this time, the car was this many miles, and that was the closest to home that it got. The letter B is going to be the same thing, except it's asking when is the car farthest from home? All right, so like the exact opposite question. Farthest from home means the maximum. That's when your derivative changes positive to negative. So we're literally going to just repeat exactly what we did in part A, but for the other critical point. So if you go back to your graph, here's where we change from positive to negative. I'm just going to repeat this process for this critical point. So second trace, we want to find a 0. It looks like it's really, really close to 10. So I'm going to make my left bound 9 enter, my right bound 11 enter, and my guess 10 enter. You can also do that by using the arrows and moving the cursor around. I just find it easier to manually type it. That's how I do it. So it's close to 10, 9.747 hours. Again, you have to put the units on this. I'm going to take off on every single problem repeatedly if you don't have units. Conversely, if you totally lose your mind, as long as you make up something and put units, then I can give you credit for the units. So the units are worth something here. Right, so at that time, that's when the car was furthest away. That's because all of this positive accumulation is the car driving away from home. I say the car driving as though there wasn't like a driver. Like the car was doing this all by itself, right? So the car was moving away from home. That's the time when it's furthest away. Again, we're going to store that. And you can copy this exactly. Like it's the exact same answer. Like part A and it's exactly like this on your test too. Part A and part B are literally like the same question. You can just write the same thing again. All right, so we're gonna quit out of here, go back to the home screen. I'm gonna hit X, enter, bring it back. Store it as A, store alpha A, enter. And then you don't have to type this again because you already typed it. I'm just gonna hit up until I bring it back. It's right there. And hit enter again. You don't even have to change anything. You restored a new A and it still says A. Like, look, that's still integral 0 to A. Just hit enter and it will give you the new answer. Hey, this is a way bigger number. Does that make sense? 214.077 miles. Why did we get such a bigger answer this time than that time? Yeah, good. It's furthest away. The car drove. Good. I keep saying the car drove as though there wasn't a person driving. The car was furthest away from home. So this is going to be a bigger result than that one. All right, letter C. Find the value of integral 0 to 11 r of t dt. All right, this is like maybe the most gimme question on the test. All you have to do is type that in. So I'm going to go back and get this. And I'm going to change the A to an 11. Here's the only common mistake I do see on this one. People will go back and change the A to 11 and leave the 65 in there. You have to delete that 65. There's not a 65 plus in front of this, so you have to delete that. So the way you delete that is right here, this DEL, that's your delete key. So I'm just going to delete that 65 plus. That's the only mistake people typically make on this one is they'll accidentally still leave that in there. If you're scared you're going to do that, then just type the whole thing over again. You just want it to be 0 to 11 r of t dt, and then there's the answer. That's literally it, 128.104. And then you have to explain what it means. All right, so what was our word? I'll give you a hint. It begins with a D for this integral. What was our word for this? Because we're going to explain what this is. What was our vocabulary word for this? Will not be total distance, but hold on to that one. I'm kind of nervous nobody's answering me here. Come on, guys. Do we need to play hangman? I told you it began with a D. No one wants to even pick letters? There we go. Thank you, Michaela. Displacement. That should not have been that hard, right? This is displacement in what? Displacement in what units? Hint, they're given in the problem. Miles, good. And you have to say something else to get the point. It's displacement in miles, and then what else do you have to say? Good, it is over what hours? The hours is correct. Over, good, I would take over 11 hours. I would want you to mention the 0 to. I usually say from when to when, so 0 to 11 hours. I would take over 11 hours though, because it did start at 0, but from 0 to 11 hours. All right, that was like pulling teeth. I hope this one goes a little bit better. Part D is largely the exact same question. I'm gonna have to bend this paper down so that you guys can see this. I can't fit all this on the same screen. All right, find the value of, and then it's that absolute value. Now, unfortunately, we are going to have to type this entire thing over again because you can't like go back and just shimmy an absolute value into there. All right, so I'm going to have to type it all again. So math 9, 0 to 11, absolute value is in the math menu. It's math number abs, and then I'm going to type this entire equation again. So negative 1/4 x to the third plus 5 halves x squared minus 6 dx. It's going to take it a minute, so you have to be patient. When you do the absolute value one, it's complicated. It's doing a lot of like complex calculations. We're going to get a bigger answer this time. Why? Why is this answer going to be larger? Like it should be a lot. Look, it's a lot bigger. Why is that a bigger answer? Yeah, good. It's total. So it's not counting the negatives as negatives. It's counting all the negatives as positive, all right? So this is total distance, again, in miles from 0 to 11 hours. All right, and then last one. All right, determine the value of, and then it's an integral of a derivative. Integral and derivative undo each other. You would just be back to r of t such that 0 to 11. Again, the integral and the derivative cancel out, just be r of t, 0 to 11, upper boundary minus lower boundary. And then we're going to plug those into r. I'm going to have to take this off here. I can't hold on to this all at the same time anymore. All right, so we're going to plug 11 into that rate function. So it's negative 1/4 times 11 cubed plus 5 halves times 11 squared minus 6. So I just took 11 and plugged it into the function. So it's negative 1/4 times 11 cubed plus 5 halves times 11 squared minus 6. All right, that is negative 36.25 minus, and then r of 0, if you plug in 0, you're going to get negative 6. Now you can leave it like that. I'm going to go ahead and simplify that down because it's not going to be too difficult. That's just going to be, what is that? This will be plus 6, so negative 30.25. And then we have to explain what that means. Now this is r of t. R of t is a rate, something per something else. It's miles per hour. So over this time interval, 0 to 11, Did the rate increase or did the rate decrease? What happens to the rate, this R of t, over these 11 hours? Did it go up or did it go down? Don't overthink it, guys. It's negative. So what did it do? Yeah, it went down, decreased. Over those 11 hours, it went down. All right. So the rate, R of t, decreased 30.25 miles per hour from 0 to 11 hours. If you get a positive result here, then the rate increased. Now notice I didn't put a negative, that's because I said decrease. If you say decreased negative amount, that's like a double negative.